Hi, I'm Abby, and this is my project 2. So for this project, I was assigned Series C, which is 2k over k to the k. So I am looking for what the end behavior is. So to do this, I'm going to apply a few different tests and find out if it converges or diverges. So for the first test I'm going to apply is the divergence test. And I'm applying this one because it doesn't require any specific conditions besides being a series, and this is a great place to start so that we can at least determine if it will diverge easily by just taking the limit of our series. So I take the limit down here, as you can see, and k to the k on the bottom is going to go to infinity much faster than the top will based on this order down here that we have. So our limit is going to equal 0, which we see is going to be inconclusive for this one. So the divergence test does not work for this, and we will figure out later why that is. So next I'm going to try the root test. The conditions for a root test are that a has to be greater than 0, and we see that the series works for that, right? This is greater than 0, and this series basically screams I should try the root test, since both of these things are raised to a power of k. So we can really easily just take the kth root of them, and I'm taking the kth root of the absolute value of the series so that we can determine if it's going to absolutely converge, if it does converge. So taking the limit of the kth square root, the kth root of it, our k's go away, and we're left with 2 over k. So we'll take the limit of that, and k is going to go to infinity on the bottom, so we're going to get 0. And we see that r is less than 1. So if we look at our conditions, we know it converges absolutely based on the root test. So let's try one more just to check our work. The next one I chose to work with was the geometric series. And the geometric series needs to be in the form where it's some constant value x is raised to the power k. So I need to make my series look like that, and it doesn't quite, but we can tell that this value k down here, if it's greater than 2, this term x is going to be less than 1, which means that our series will converge. So we know that k is approaching infinity, right? So k will equal infinity, and we know that infinity is greater than 2. So 2 divided by infinity, this term is going to be less than 1. This is our x term. So based on the geometric series test, we can determine that our series will also converge absolutely, because we took the absolute value of it when we did this test. So to look at kind of the big picture of things, I want to show you guys the graph. So here's a picture of the graph at x equals 1, and we can determine that, look at that, it's converging as it goes off into infinity. It's getting less and less, and it's going to converge to some number way out here. And basically, the big question I want to ask is, why is this end behavior important? And I think the main reason that we're focusing so much on these infinite series and what they're doing at the end is because we need to be able to approximate where the power series makes sense for our interval of convergence now that we're working with the power series. And the power series is really helpful for us because it puts more traditionally defined functions, and it expands them out into polynomials, which is easier for us to understand and has applications in engineering and finance. So hopefully all of this practice with convergence and divergence will help us as we move on to the power series. So thank you. Let me know if you have any questions. Have a good night.